All right, chapter 2 starts now. Now, obviously, we won't be able to start and finish the whole thing with just basically 3.5 weeks left of school before final. All right, because we have the rest of this week, next week, then Thanksgiving break, then 2 weeks, and then finals. Okay, so we'll see how far we get, and we'll stop before that finals week and kind of start reviewing for what's going to be on there. So I'd probably like to spend like the last week before finals, just kind of doing kind of just a big overview of what we've done before. Chapter 1 is all about lines, right? Just powers of 1 that are attached to x. Chapter 2 is all about things that have x squared, and that's quadratics. Okay, quadratic function. So everything that you're going to see is going to be y equals x squared. And it'll just have some numbers being added, subtracted, multiplied, divided, negatives, whatever. All right. We're going to look at section 2.1 to start, which looks at just one version of quadratics, making it look one way and not another. Okay. And so that's called vertex. You guys know what a vertex is when it comes to a parabola? Nice, yeah, perfect. All right, because what most of them are going to look like are just like that, right? That nice U shape. All right, they're always going to look like that, or I mean, they could be upside down. It doesn't matter whether they're right side up or upside down. Doesn't make a difference. We'll look at what the equation does to do that, but that vertex is just a turning point, right? Either that lowest point, if it's right side up, they call it right side up, opens upward, or upside down. Nice, it can be the highest point if we flip that thing upside down. And we already know about all these transformations with horizontal shifts and vertical shifts. So this section is actually going to be, I think, pretty much what we did in 1.2 with transformations. And that's really what vertex form tries to get us to do, is connect what we already know about horizontal shift, left 3, and vertical shift, up 2, and vertical stretch, and all that, reflections and flipping stuff upside down, all that kind of stuff that goes with it. So the vertex itself is just a turning point, right? It's going to be either a minimum if it looks like this, or a maximum if it looks like this. Right, it's going to be either the highest point or the lowest point. And that's pretty self-explanatory, min and max, cool. But what does vertex form actually look like? It looks like all of the stuff that we did in 1.2 with transformations, which is really nice, that we have this background to kind of get this chapter started. Because what we'll do in 2.2 is we'll just kind of, we'll change how it looks. You know, it won't look quite like this. But what you'll be able to see with vertex form is we'll take like this y equal x squared, and we'll just move it around, right? We'll shift it, we'll stretch it, we'll reflect it, we'll do all that stuff that we did with transformations. But I'm not going to use this whole y equals anymore. These are functions. So while y equals is nice, I want to start using function notation instead. You know what that looks like? Instead of y equals, f of x. Yeah. So I'm not going to call it y anymore. It is. It just means y. But I want to be able to say, like, here's f of x, and over here is g of x, and over here is h of x, and over here is a of x, or p of x, or whatever name I want to give it. What's nice about function notation is that you can look at different equations at the same time and use different letters to talk about them separately. Instead of y equals, y equals, y equals, y equals, then I don't know which one I'm talking about. And so here's what vertex form looks like. You're just going to see A stretch, shifts, up and down, left and right. Right? All that stuff from transformations, all kind of in one place. All right. So if I called this f of x, I could call this g of x, h of x, a of x. I could use f of x again if I really wanted to. It doesn't matter. Okay. I'm going to use q of x because it's quadratic. Who cares? Or I could use v of x because it's vertex form. It doesn't matter, right? I could call it f of x. It's just the name of the function. Okay. But what you'll see in what I'm about to write is buried in there an x squared. Okay. But I want to include a vertical stretch or compression. I want to include horizontal shifts and vertical shifts. Okay. So leave a little space right here for a second. Okay. Parentheses. So I want to be able to do horizontal stuff. That all happens on the inside, right? So I'm just going to leave a little space here right after the x as well. I'm going to close it and put the squared up there. Because there it is. Now it's quadratic. X somewhere squared. Okay. But I want to include a spot for my vertical stretches and compressions. I'm not even going to do horizontal stretches and compressions because I can kind of lump those together to be vertical because like if I stretch it out vertically, it kind of gets, I better do this in front of the camera. It's going to get skinnier this way. Or if I do a horizontal compression, it's going to get skinnier this way. So they can kind of be lumped. Okay. But I want to have something right here, maybe something right here, and then something out here, right? A spot out here for my vertical stretches or compressions. And kind of at the same time, remember that negative that flips it upside down, it'll also be a spot for that vertical reflection. Okay, so that'll be in there. Now, if I do that, if I change that number in front of x squared, so write that down and then look over at the projector when you're ready. All right, so whatever that number is, that'll be the vertical stretch if it's bigger than 1. The compression if it's between 0 and 1. And it'll be a reflection if that thing's negative. But take a look at where the vertex is, right? That turning point right now. If I put a 2 in front, does it move the vertex? Or a 3? Or a 5? Like, does that turning point at the bottom stay in the same spot? Absolutely, right? So even like negative 2. Yeah, okay, flipped it upside down, vertical stretch by 2, all that stuff happens. But does the vertex move? Absolutely not. Okay, so whatever that number is will not make a difference to where the vertex is located. It's always going to be when it's just x equals or some number x equals, your vertex will always be at the origin of 0, 0. Okay, changing the number in front, making it big, making it small, making it positive or negative, that doesn't change. Okay. Now, because that number can basically be whatever we want, I want to put a little placeholder right here. I want to put a letter right there as kind of just a spot for some unknown constant that we'll want to keep track of when we're graphing, when we're solving stuff. But I don't want to put x because that's x, right? And usually letters at the end of the alphabet are for variables, like numbers that we're going to plug in and it can change within the function. The numbers at the beginning of the alphabet are for those unknown constants that once I make that choice for f of x, it stays that number. Or, all right, here's g of x. I'm going to make a choice. Boom, that number is that number. So letters at the end for variables, letters at the beginning of the alphabet for unknown constants. So that's why I'm just going to call it a. Okay. A is going to be some number. But I want to just speak to it kind of just in general. All right, so I'm just going to use the letter A. Okay, cool. Now for the number on the inside. If I drop in, and again, I'm not going to multiply by anything on the inside. I'm just going to add and subtract just to make our lives a little bit easier. If I like add 3, did that move the vertex? Absolutely, right? But did it go left or did it go right? It went to -3, right? It's the opposite of the number that we're looking for, right? -2, it split it over to the right 2 spots, which makes sense, right? Horizontal transformations are backwards, all that stuff from like a month ago, all kind of being used now to figure out where that vertex is, right? And so the issue with what I'm about to write inside here that we just want to keep track of, and I'm going to let the math kind of take control of that, is that the number is going to be switched, okay? And so what I'm going to do in here, instead of putting like plus some constant, I want to remember to switch the signs, so I'm going to put minus. Okay, so inside here is going to be x minus something, but that something doesn't necessarily have to be negative versus positive. We're always just going to switch the sign, okay? But what I want to do right in here is start to create an understanding that that number is going to be the x value of the vertex where we're at. Hi, Miss Sigmund. What's up? You know it. On my desk of goodies. There you go. You know, I shared the walkthrough, the PDF of that with him too, and just put it on Canvas. So I made like a lesson 3.1 through 3.7 assignment, and I just linked it there. Okay. But I know the handout's kind of nice. Sweet. That's right, Sigmund. All right. So in here is going to be like the x part of the vertex, right? So here's my vertex of whatever it is, right? There it is. It's going to be right there. And it's just going to be some number, right? And maybe it's 0. Maybe my x value is 0. That's all good. But it could be 1 or 2 or -3 or whatever. I just want to make sure I switch the sign. Now, this isn't my choice for what this letter is. This is like the math gods have already decided, right? People way smarter than me way long ago decided what this letter should be. Right? And it kind of makes sense because it's a horizontal shift. What letter do you think they use? H. Okay, but I'm going to put x minus h because I want you to remember to switch the sign. Okay, so this is just h, right? It's not negative h. It's the opposite of whatever's inside, right? X minus 2, where's the vertex? 2, right? The opposite of negative 2. Cool. Now I just want to be able to move this stuff up and down. That's going to happen on the outside. I'll go back to regular x squared. I'll keep it in parentheses, that doesn't matter. Let's say if I added 1. Where's the y value of the vertex? Up 1, right? At positive 1. If I do like minus 2, where's the y value, right? -2. That sign is correct. Whatever the sign is of that value is exactly the y value of the vertex where we're at. And we can do both, right? I could put x plus 3, okay, so -3, right? The opposite. And then -2, okay, down 2. So this sign is going to switch. That one's going to stay the same. Whatever it is, we liked those vertical shifts because they went in the direction we expected. So I put a minus right here to remind you to switch the sign. I'm going to put a plus right there to remind you to keep the sign the same. Now, that's a vertical shift. What letter would you think might make sense? V, right? But that's way at the end of the alphabet, which for us, like seems like a variable that I want to plug stuff in. We'll use V for like velocity and stuff like that when we get a little further up in math. So I think this letter just came from a different language. People that spoke English did not create math, right? We're just kind of standing on the shoulders of giants. I didn't make this one, somebody else did. They call it K. A letter towards the beginning of the alphabet. And there's your vertex. And so what I should be able to do now is look at an equation and find the vertex without actually having to do any work. And vice versa, like here's the function, there it is. I know where the vertex is. I can come up with the equation. Okay, so that's what I kind of want to start with right here. There's really like 2 directions we're going to go. Here's the equation, what's the vertex? And here's the equation, where's the vertex? Or here's the graph, where's the vertex? Or what's the equation? Sorry, my mind is crazy today. Here's the equation. So let's say this. Part one. Let me slide this over. Because there's just two things we want to be comfortable doing. Hopefully you guys can see past the books. Okay, cool. All right, so part one. Given the equation, find the vertex. Okay, that's what we're going to start with. Okay, and then it'll be part two. Given whether it's the graph itself or just given the vertex, find the equation. So we're just going to be able to go in both directions. All right, but we'll start with part one. I should probably put a 2. Cool. And what's nice about this kind of early stuff in this chapter is, one, we already know how to do it because we know transformations really well. And two, there's not a lot of like math to do necessarily. We just have to know that that's our setup. Given the vertex, find the equation. Cool. All right, I just want to do a few, and we'll see how we do, and then we'll move on. 2.1 will be done. All right, so I'm going to give you an equation. Call it f of x. Find the vertex. Okay, so jot that one down. That's the problem. The answer is just going to go right below. I don't have to do any work, which is really nice. We're just going to find the vertex. So the question's in blue. The answer, I'm going to write in black so you can see it. It's some point, some xy. And if you can go back to that kind of vertex form here with all the A's and H's and K's and stuff, and ignore whatever number's in front, it's really just about the number on the inside and the number on the outside. Then you've got it. Okay. Perfect. Right? Switch the sign of the number on the inside because horizontal transformations are backwards, and keep the sign of the number on the outside, and that's it. Ta-da, done. Okay. And if we have the skill on how to graph these, which we'll get to eventually, then I can just start at the vertex because that's an easy point to start, and then there's this nice algorithm on how to get up from there. Cool. Number 2. I'm going to switch the name because I already used f of x, so I'm going to call this one g of x. Okay, f of x is probably the most common one because f function, that kind of makes sense. 2x plus 1 squared minus 6. Just kind of jot that down. Write down the function. G of x equals 2 parentheses x plus 1 squared minus 6. And we just want to find that turning point. We just want to find that turning point. Go ahead, Margaret. What do you got? Perfect. Switch the sign of the one on the inside because horizontal transformations are backwards, right? This is left one, so left means negative, right? And then keep the sign of this one. Cool. What about that 2? Why didn't you include that? Couldn't have said it any better, right? It's the stretch factor. It doesn't make any difference to the location of that vertex. It'll just change how we connect all the points to it. It's just going to go up fast. And it'll go up twice as fast. All right, one more. F, G, H. H of x, negative 5 x minus 1/2 squared plus 7/3. Find the vertex. If I can find the vertex, graphing this gets a lot easier. And that's what we'll get to. Eventually, we'll be able to graph these by hand. And we'll see how time allows. I'm kind of picking and choosing what I think is important. I'd rather you understand the math behind it than actually physically graphing. Maybe we got calculators that can do that. Cool. Somebody besides Margaret, since she's killing it today. Let's see who else we got. Yeah, Sean, what do you got? Good, right? Switch the sign and keep it the same. And yeah, those numbers are gross, right? But they're perfect and they're done. All right? Good. Now I want to ask a kind of a follow-up question. Is that point a minimum for that function, or is it a maximum for that function? Well, it depends on each one, right? It's going to be one or the other, right? It's going to be a minimum if it's that lowest point because the thing opens upward, and it's going to be a maximum if it opens downward, okay? And so we just have to figure out what makes it open up and what makes it open down. Well, what about regular plain old x squared? Like no changes at all. What happens when we just do x squared? Does that have a minimum or does that have a maximum? It's got a minimum, right? Because it's the lowest point on the graph and all the other ones go up from there, right? So plain old regular x squared is going to be that. It's going to open upward. What's that number sitting in front right now if we don't bother writing it? 1. Nice. Is that positive or negative? Positive 1, right? And look what happens. Positive 2. Is it still a minimum? Positive 5 is still a minimum? Even positive 1/2, is it still a minimum? What's going to make that graph flip upside down? A negative. Perfect, right? Because that negative out in front, that was our vertical reflection, okay? And so if you want it to have a minimum, I want the number in front to be bigger than 0. I don't care how big it is as long as it's bigger than 0. What was the letter that we chose for that number in front? A. If A is greater than 0, come on. If A is greater than 0, it's going to have a minimum. Okay? If A is less than 0, it's going to have a minimum. And so I don't even have to graph these to know whether my vertex is a min or a max. I just have to look at the sign of that first number. Right? What's that? So if you put a 0 in front, right, it's multiplication, right? And what's 0 times anything? And look what happens. The graph disappears, and it's just y equals 0 now, right? It's the line that is the x-axis. Because 0 times x squared is 0, and so we go from y equals 0x squared to really just y equals 0. Right? These two are the same graph. Red graph, blue graph. Red graph, this is 0, right? Because everything disappears. And if you don't have an x, it's just a flat line. This is constant. Okay? So now we can make the choice. What's the number in front right here if we don't bother writing it? 1. A positive 1, right? So is it going to be a min or a max if it opens up like that? This point right here, is it the lowest point or the highest point? So min or max? Minimum or maximum? There you go. Good. It's a minimum. Cool. Okay, so the vertex is all about these numbers, right? The h and the k. I wish I knew what the k stood for. I honestly don't know. And I'm just making up that h is horizontal. I don't know if that's really what it is either. That's how I remember that, though. This number out in front will tell you what's called the orientation of the function, whether it opens up or it opens down. So what about this one? So I guess first, let's talk about the orientation. I'll sneak it in here. Does this graph open up or down? Is this number positive or negative? The number is positive. It's going to open up. right? It's going to look the way we expect it, because plain old x squared is really just 1 x squared. So this graph is going to look like that, somewhat, right? It's not perfect. I'm just sketching it. So is this point right here a minimum or a max? And you can just write the word min, that's fine. How about h? Function h. Now, I can just say that, and you know what I'm talking about. Is that going to open up like this, or is it going to open down? Why? What's negative? Be less specific. Not just 5. Like, just talk to me in general about which number. Say it.
A is negative.
A, right? And just saying like that. Oh, okay, the leading coefficient. Nice. A is negative, right? A is positive. A is positive. A is negative. I'm just going to use that greater than 0 versus less than 0. Right? Greater than, less than. So is this point a min or a max? Beautiful. Done. There you go. Part 1, done. Now let's go the other way. Okay, I'll call it 4. I'm going to give you the vertex. Now, I'm not going to tell you what A is to start, but we can always add that in and you just drop it in. What I could tell you is whether the vertex is a min or a maximum, and then we can make up an A that works. Okay, so let's say I give you the point 4, 2. And I tell you that that is a minimum. Let's make up a function where that's true, which actually gives you a little bit of wiggle room, right? You don't have to be all writing the same exact function, because we can make whatever stretch we want happen, because it's not going to affect the location of the vertex. As long as the sign of A is good, we're good. All right, so we used F, we used G, we used H. Let's pick another letter. Any letter you want that we just haven't used. B, sounds good. B of X equals. Now, you want to use F of X every time? That's fine. Right? It's a different problem, so you can use them over and over again. I like to mix it up. Now, here's my kind of like my general setup. Some number right here, parentheses, X, some number right here, squared, and some number right there. Right? Just how I kind of started, right? That's how I created Q of X from the beginning. I said, all right, leave a little space, leave a little space, leave a little space. All right, let's start with the number in front. That's first. That sounds good. If this is a minimum, what is the sign of A? Positive, right? Because it's got to open up. And if it opens up this way, God, I keep forgetting I'm on camera. If it opens up this way, it's just got to be positive, which means it's a minimum. So let's pick a positive number, any number you want. How about 1, right? Do I need to write the 1? Then I'm not going to. Stop writing this as a number, as a setup. Stop writing that. Drop the 1. Okay, it's going to save you a whole bunch of trouble. Okay, cool. So, great, done. Let's put the correct numbers now inside. If your X value is 4, what has to go on the inside? The opposite. Good. Horizontal shift, right 4. Perfect. If your Y value is 2, what's got to go out here? And what sign should I put in between if this is positive 2? Plus. Remember, your horizontal value is the opposite, because horizontal transformations are backwards, but the vertical one is the direction we want. And if I want to go up 2, I better do a plus. Done. There it is. That looks good. And that's it, right? That's all we really need to think about. It's more of a thinking first section here, and we'll get to some algebraic stuff for sure. in this chapter. A lot of different things are going to happen in this chapter as we kind of work through it. But for now, I wanted you to use your brains for a second. All right, let's do like a -5, -1. And what if I told you that it was a minimum? So I know that this graph takes a turn, -5, -1, and it's going to be the lowest point on this graph. So that's the thing about these, remember what these shapes are called? Because the functions are quadratic, but what's the shape, the U shape? And let's spell it right. P-A-R-A-B-O-L-A. Parabola is how it's phonetically said, but obviously parabola. We're going to put the emphasis on that second syllable. Cool. Sweet. Let's do it. Let's name this function something else. T. Dude, I looked right at you and I thought T. That's crazy. Now, careful with your T's though. What does that kind of look like in math? Don't write a T like that. It's going to think, you might think it's a plus sign. Whoever's reading it might put a little tail on the end of your T's. Okay, T of X. Again, I'm going to leave a little spot right here. I'm going to put an X. I'm going to leave a little spot. I'm going to put a square. Let's pick a different A value, but still makes a minimum. Because they didn't specify if there was a stretch or not. We just know it's got to be orientated up. That's it. Let's pick a new number. What does the sign of this number have to be if it's a minimum? It's got to be positive. So pick a positive number. That's just not 1. Sweet. Love it. Works. Cool. All right. X value of your vertex, H, right? H is -5, so what's got to go in the inside? The opposite. Good. K is -1, so what goes out here? Done. Perfect. You guys are killing it. All right, let's do one more. All right, vertex. 7, 0. And it's a maximum. All right, so the vertex is over at 7, and y value is 0. And it is the highest point on the graph. Let's come up with a function where that is true. Again, some wiggle room there, because we don't know anything about the stretch, and that's okay, we might not. But let's give it a new name. G, F, H, B, T, give me another one. D? Sounds good. D for Dylan. D of X equals. I'm going to leave a little spot. X, leave a little spot. Square, leave a little spot. And you don't have to do it that way, but it's nice to kind of have some empty space to work with just to get it going. All right, let's start at the beginning. All right after the equal sign. It's a maximum now. What does the sign of this have to be if it's upside down? It's got to be negative, right? Pick a number. So should I write -1? Just a negative. Okay, negative parentheses. Now we can go. Cool. If that was a 0, so that's what she asked, right? If I drop a 0 in front, it's not a parabola anymore. It's not quadratic because 0 times anything is 0, and the x squared disappears. And so that's why when I created this setup of either being positive or negative, I had to leave off 0. I couldn't include that number because that x squared term would disappear. Good question. Cool. All right. H is 7. What goes inside? -7. -7. Love it. All right, don't put a +0. It doesn't make a difference. Right? Adding 0 doesn't change anything. And so if you do have a 0 value somewhere, we're just not going to include that. Right? We're not going to put a +0. We can understand that that's there. Just like this, I know it's a 1 right here, which means there is no stretch. It's just flipped upside down. And so the same thing would be true. Let's just do one more. I got the space because that brought up a good thing. I didn't even think about doing it like that. Like, what if it was 0, comma, pick a number we haven't used it, like -3 or something. Let's make it a max. Let's pick a new name. B, T, D, H, F, G, Q, mix it up. J for Johnny. J of X. Boom. All right, this one's Johnny's function. I'm not even going to put the whole blanks. Let's just work from left to right. Because we got to build this ourselves from scratch eventually, right? I can't give you the setup every time. Let's go from left to right. All right, first thing after the equal sign is that A, right? Going to tell us really about the orientation, right? If it's a maximum, positive or negative? Negative, right? So let's pick a new number, negative something. Say it again. So remember, the number in front doesn't change the location of the vertex. Right, 1, 2, 3, 4, they're all still there, right? That doesn't change. Now 0 is H, right? A. So did you both say -4 or -5, or did you like one you said? You said -5. Cool. How about -4.5? What's the difference? Decimals are fine. Fractions are fine. They happen. It's all good. In fact, we're going to need them big time here in a couple sections. Cool. What happens right after the A? Now that we put that in, what's the next thing I better draw? Parentheses, right? Cool. What's definitely coming next? What's after the parentheses? Now remember, that's a spot for a variable. When we're just writing the function, we're never going to change that. Right? A, H, and K, those will be numbers. But X and F of X or G of X or H of X, whatever it is, we're going to leave those until we have actual spots in this graph that we want to solve for. Okay. What's next? Minus. Okay. And then H. Gavin? Like subtracting 0, right? Is that necessary? No. Okay, so now if I close that, is there anything inside that the parentheses are really requiring me to like keep track of? Lose them. I know I did that on purpose. I apologize for making you erase that, but I wanted to really drive that point home that if you don't have a horizontal shift, you don't need parentheses. Because the number outside, A, whatever it is connected by multiplication. And right, so X minus 0, don't need it. Okay, close parentheses, don't need them. What's next? What do I need right after that X if I want it to be quadratic? Good, thank you, Johnny. Gotta have X squared somewhere if you want it to be shaped like this. Now, put the parentheses, you're not wrong. It's just X. It's like putting one X instead of just X. You're not wrong. I'm never going to take off points or something like that, but it's just simpler. Right? Right, parentheses are only necessary if you are adding and subtracting stuff on each side. All right, what's next though after the squared? We still have that plus K. There's K right there. So what -3, what should I put right here? -3. Good. Done. And let's prove it. Let's make sure that we believe it. -4.5x -3. Vertex at 0, -3. It's a maximum. And so you always have the graphs to back you up. You've got whatever you've got in your hands, right? Calculator, phone, laptop, something that can do some graphing for you, use it, right? Because what's nice about all of this, as nice as it is to kind of have the math that goes on behind it, you can always kind of back it up with whatever the graph tells you, okay? So I'm going to need some important stuff along the way just to make sure it looks good. But the graph can do a lot of that work for you, so you're feeling pretty good about it. Cool? Honestly, let me check. So I'm in the textbook. I know we haven't been in there in a while, right? But just as a reminder, I don't know if I'm going to assign anything in here just yet. Clever.com. I log myself in a little bit differently than you guys log yourselves in, but eventually we kind of do the same thing. We get to that Savas Realize. This is what it looks like on my side. You would have like assignments listed here, right? I have no new assignments. And here's our textbook. Topic 2, so chapter 2, quadratic functions. 2.1 Vertex 1. Let's see if I did it all. Transformations, talked about it. Writing an equation, talked about it. Writing an equation of a parabola given the graph, that's really just me giving you the vertex. Write an equation of a transform function, right? Horizontal shift, left and up, boom, done. We kind of all did that. Done. I'm good. Section 2.1, one day, that's all it took, okay? What I'm gonna give you tonight, I'll send this out, will just be practice with part 1 and part 2. Okay, I'm going to say, okay, part 1, here's an equation, find the vertex, and the orientation, and decide if it's a min or a max. And then I'll do part 2, right? Here's a vertex. Here's the characteristic. Here's the location of the vertex, whether it's a min or a max. Come up with your own function. Okay. And 2.1 done. Cool. Questions? It seemed like you got it. It seemed like that clicked pretty well. But that's just me walking you through it. So it might be a little bit trickier tonight, tomorrow, Friday, whenever you get this done. This will be due. I don't know. Friday. Make it Friday. So we'll give you a couple of days to get it done. But it'll probably be more than that because those are relatively quick. And then 2.2 on Monday. Okay. This is recording, so I'm gonna stop that recording because I think we're good. And if you ever needed to like go back and look at